Okay, here for another episode on nutrient management for this field notes. We're going to talk with Hava Blair. Hava is the nutrient management specialist and SNAP Plus lead for the UW-Madison College of Agriculture and Life Sciences. And then we also have Andrea Topper, who is with the Department of Ag, Trade, and Consumer Protection. Andrea is a nutrient management outreach specialist for the department. And we're going to be talking a little bit about soil conservation, nutrient runoff, and all those different formulas and calculations that sort of run our decision making for conservation plans here in the state. So, Andrea, we have a lot of fragile landscapes that we farm here in Wisconsin. They're fragile in different ways, but more often than not, we're dealing with something that needs protecting on our farms. How does soil loss get calculated when we develop conservation plans on Wisconsin farms?
That's a great question. And in Wisconsin, we are super lucky to have the SNAP Plus software. I know that it's been mentioned probably every single time we've talked about nutrient management here on the podcast, but SNAP Plus is what we as nutrient management planners use to write nutrient management plans. And within SNAP Plus, they have built out the Russell II equation. We use Russell II to help us calculate soil loss. Each soil type is going to have a different T value or a tolerable amount of soil loss that can happen. And that can range from 1 to 5 tons of soil per year that can be lost. And so depending on the soil types that you have in your field, you could see a range of a 1T soil all the way up to a 5T soil. And in nutrient management planning, across your rotation, you need to meet T. So we need to make sure that if our soil loss is 5 tons of soil loss per acre per year, we're not exceeding that in our rotation. We have a lot of soils that could fall within our field. So how are we picking and choosing which ones to utilize in that Russell II equation? First, we have our critical soil type. Our critical soil type is going to be the one that is most erosive, the one that has most likely to leave that field. And within some of the criteria that they've built in the background, that critical soil type must take up at least 10% of your field. If that soil type is taking up at least 10% of the field and it is the most critical, that is what SNAP Plus is going to be using in the background to calculate out your soil loss and determine your T value. Additionally, it's not specific to soil loss, but I want to throw it in there, our predominant soil types. Our predominant soils are going to be the soils that are most commonly found throughout that field. And that is going to then determine what we are going to be using for our fertility recommendations. So sometimes people get concerned that, oh, we're only concerned about that critical soil type and it's only taking up 10% of the field. How can we be building our nutrient management recommendations off of that critical soil type? And that's not the case. SNAP Plus in the background is using that predominant soil type. So taking into consideration that soil type that takes up most of the field, that's what's going to be determining our fertility recommendations.
I always like to sort of point out we want to hold ourselves to a higher standard when it comes to that soil erosion prevention, and that's why we choose that 10%. Even though it is only 10%, it's an important 10%. So I kind of like to approach it as well. So Hava, tying into that soil erosion piece a little bit more, one thing that's unique to Wisconsin is this Phosphorus Index, or PI. People may see that on a report if they're working in SNAP Plus. Tell us a little bit more about what it is and what goes into producing a number for a particular farm.
Absolutely, yeah. So the Phosphorus Index is a model, and it's a way that we estimate the amount of phosphorus that's being lost in runoff in both sediment forms and dissolved forms. So we're interested in phosphorus as a nutrient because we know that it can create concerns for surface water quality. And what we can do based on the information that people are entering in SNAP Plus in their nutrient management plan, we know about the crops they're planting and nutrient applications, manure, fertilizer, what kind of tillage are they using, what kind of yield are they getting. So what we're able to do is take all of that into account and figure out what are the different sources of phosphorus coming from the soil and the manure and the fertilizer. And then we think about how is that phosphorus transported off the field in surface runoff. And we're really only concerned with the surface here. I mean, of course, if your field is tile drained or you have water infiltrating into the field, certainly that can carry phosphorus too. But what we're thinking about in the phosphorus index is phosphorus moving to the edge of the field and being delivered to the closest surface water body, because that's kind of what we're thinking about. We want to keep those nutrients in the field. We want to keep the phosphorus in the field. And so in the phosphorus index model, we're doing calculations, like I said, to account for all these different things and basically say, how much phosphorus are these different pools contributing, the soil and the fertilizer and the manure. And then soil loss or erosion coming from Russell 2 is actually a key part of this too, because we want to know how much sediment is being transported in runoff, because we know that sediment-bound phosphorus for many fields is a major chunk. It's a major, makes up a big part of the phosphorus that you're losing in the stuff that's actually bound in the sediment in the soil. So all of those things that Andrea was saying with Russell 2 and the critical soil, those are incorporated into the phosphorus index because we're getting our soil loss or our sediment estimate from the phosphorus, or from the Russell 2 rather. And I just wanted to maybe comment a little bit more about like, what is this Russell 2 model that we've been talking about? And if you've taken a soil class in the last 5 decades, you've probably heard of the universal soil loss equation, or USSL. And so Russell 2 is the revised universal soil loss equation 2. And some of the things that are like happening in the background that I think it's good to know about, because we're not just making up these numbers, right? Like, we're thinking about the unique characteristics of the field and of the cropping system. And the amazing thing about Russell 2 is that it allows us to think about what is unique to that soil, like highly erodible soils, the critical soils that Andrea was talking about. Let's think about the slope and the length of the slope. And then let's also think about the impact of all of your different field operations and cropping practices, the cover on the field, the residue on the field. And just to throw in there, we can also incorporate supporting practices like edge of field filter strips. So this Russell 2 model has a lot going on. It's a complex model. There's a lot of pieces, and we're lucky to be able to incorporate it into SNAP Plus because it allows us to be so much more specific about different field situations and account for all of those different types of things when we're estimating how much soil is being lost. And then when we calculate the phosphorus index, that gets rolled into our calculation of phosphorus lost.
Mm-hmm. So I remember when I first got introduced to that universal soil loss equation, we actually did like plunk it out by hand on a whiteboard. Can you achieve that number or know what that number is for your phosphorus index by hand?
No, you really have to run Russell 2. I think that's the biggest barrier there to doing it by hand, is that the current version of the Russell 2 model that we're using has a lot of inputs. And luckily, those inputs are things that people already put in their nutrient management plan. So it would be really, really challenging to do this on your own. That's kind of why we have a piece of software. Not impossible. You know, when we test the equations in our software, I basically run this by hand, but it's a lot of work. And so you can look at all the equations that we use in the phosphorus index, but that Russell 2 piece is really the piece that you kind of have to know what you're doing. And there are a lot of people out there that still use Russell 2, you know, a lot of folks at conservation offices. But I think, again, like, we all use software every day to make our lives easier. And so I think that's kind of the idea behind having this built into SNAP Plus, because let people enter their data the one time, and then we can use these tools and these equations that are based on research that's been conducted in Wisconsin and verified and validated in Wisconsin to make some of these estimates so that we can use it as a planning tool. You know, that's really what I think I probably should have started with, that is that the phosphorus index is a planning and assessment tool, because it helps us think about the whole rotation and say, okay, where are we headed here? Am I looking like I'm going to be losing a lot of phosphorus? And if so, I can use SNAP Plus as a tool to explore different scenarios to see how I can bring that number down.
Mm-hmm. And so at its foundation, SNAP Plus and the way that we use 590 and incorporate it into our conservation planning in Wisconsin, it's heavily built on phosphorus loss reductions, specifically usually those surface phosphorus losses. In our last minute or so, this question is for either of you. How have we been doing, the past couple decades when it comes to reducing that phosphorus loss, that phosphorus loss on a statewide level? Obviously, as our cropping systems change, some metrics go up and down, but, across with all of Wisconsin, phosphorus loss, how are we doing?
That is such a good question, Landon. And it's a hard question to answer. So I'm going to try to pull from a couple data sources that I know about and just try to give people a sense of this. So one of the data points that we have to think about this question is looking at the average state or average by county soil test phosphorus results. And so here in the state of Wisconsin, part of having a nutrient management plan is that you're required to get your soil tests from a DATCAP certified laboratory. And every 5 years or so, DATCAP pulls together and publishes data about, on average, it's aggregated by county. What are the average soil test P levels in each county and then across the state? And so, average across a county, yeah, that's kind of broad, but we can look over the years and the decades and kind of track where soil test phosphorus levels are going. And I would say you certainly over the years you see an increase. And then I've looked a little bit at the last 2 5-year periods of data sets. And so maybe they're kind of leveling out, recognizing that there are reasons that those data sets are not statistically perfect. I have to say that as a scientist. But I think that that's one data point for us is we can look at soil test phosphorus levels, and we know that if people are applying much more phosphorus than is needed, then that phosphorus level is going to be building in the soil. But your question was also kind of about how much phosphorus are we losing? And I think to get at that question, it's really more about measuring phosphorus levels in the water bodies that might be receiving that phosphorus. And there, the results are more mixed. I've seen some data that suggests that we're still pretty far away from where we would like to be in terms of phosphorus levels. We still see a lot of water bodies impacted, but I don't have a great number off the top of my head to give you a percentage reduction or anything like that. But definitely, I think there's still opportunities for improvement.
Sure. No, this is a lot of data that I feel like we don't necessarily hear every day, on farms. It's not something that's, necessarily coffee hour chats or anything like that. So it's good to have a check-in every now and then. So,
absolutely.
All right. Well, thank you, Hava and Andrea, for joining us for Field Notes on this episode, and we'll have you back for future episodes.
Thanks,
Thank you
Landon.
both.
Thank you.
Thanks for listening. This has been Field Notes from UW-Madison Extension. My name is Will Fullwider, Regional Crops Educator for Dane and Dodge Counties. A big thank you to Joe Ryan for creating our theme music and to Abby Wilkie-Maki for our logo. If you have any questions about anything you've heard today or about your farming practices in general, reach out to the Extension Agriculture Educators serving your region.